Hello everyone, welcome again. Actually, it's a welcome for me because I wasn't here for a while, but now I came back with a new YouTube series which is Hack the Job, and I wanted to start with this topic to start this series. I hope you liked it. I hope you like it, and I hope I can teach you some things. So I am a little bit excited. So to beat that feeling, let's start quickly. So in this series, I will try to explain everything in detail. I will go to some additional resources like ChatGPT or Google or etc. For example, when I read these documents before, I had some questions about what is really TXT records, what is really MX records, how does it work, what do we use them for. It wasn't clear for me just reading these TryHackMe documents. And at that point, I thought maybe there are some others like me, and I can use additional resources. And while I'm teaching them, I can learn better too. So let's start with the first step. What is DNS? DNS, Domain Name System, provides a simple way for us to communicate with devices on the internet without remembering complex numbers. Much like every house has a unique address for sending mail directly to it, every computer on the internet has its own unique address to communicate with it called an IP address. An IP address looks like the following. There are 4 octets, 4 sets of digits ranging from 0 to 255, separated by a period. When you want to visit a website, it's not exactly convenient to remember this complicated set of numbers, and that's where DNS can help. So instead of remembering the IP address, you can remember the name of the website instead. So it's really easy to remember a name of the website instead of remembering the IP address. That's why DNS came for, and it is how it works actually. It changed the name of the website or target to an IP address, and with that IP address we can reach that target. As you can see here, there is an animation, and this IP address goes directly to this website, not another one. It goes to the tryhackme.com. So what does DNS stand for? It is Domain Name System. But you can think like that. Can we go another websites except tryhackme with this IP address? Actually, as I remember, of course we can. If I'm wrong, just fix me in the comments. As I remember, in headers, there is a host header, and for example, our IP addresses doesn't change, which is the same one. For example, this one, but in that host header, there's another address, which maybe goes to the another subdomain of tryhackme.com, maybe shop.tryhackme.com, maybe blog.tryhackme.com, but with the same IP address. So it means, again, if I'm wrong, fix me, correct me with your comments. In a server, and the server has one IP address, and in that server there may lots of websites maybe, and if we search for a website And if we take this IP address, maybe the IP address is some others IP address too, like google.com, like linux.org. Okay, that's all. Let me continue with task 2, domain hierarchy. We have actually three paragraphs here. First one is TLD, second level domain, and subdomain. Let's start with TLD. Before we start, let's check this photo here. Root domain and the top level domain, as you can see, it's in the second step, and in the last step we have second level domain. So the hierarchy goes like that: root and top level domain, and then second level domain. But in a name, it will goes like that. It is for top level domain. This is for the sorry. Anyway, let's continue. A TLD is the most right hand part of a domain name. It means that most by right hand, it means this one. At the right of a name, we will see top level domains. So for example, the trahecme.com, here the TLD is .com. There are two types of TLD. First one is generic top level, and the second one is country code top level domain. You can understand from the names here, it is for describing the countries for a domain, and these are for describing the purpose, generally describing the purpose of a domain. Historically, a generic top level domain was meant to tell the user domain name's purpose. For example, a .com would be for commercial purposes, or .org for an organization, or .edu for education, and .gov for government. And a country code top level domain was used for geographical purposes. For example, .k for sites based in Canada, .co.uk for sites based in the United Kingdom, and so on. Due to such demand, there is an influx of new generic top-level domains ranging from online, club, website, blog, biz, and so many more. Actually, blog is more like subdomain, but maybe you saw it as a top-level domain too. For a list of over 2000 TLDs, click here. Okay, let's click here and see what we can see. Here, as you can see, we have lots of top-level domains here, and these are the most common top 2000, and we have lots of them. Oh, these ones are really interesting. I saw them, I see it first time. And let's continue with our task. Second level domain. Taking trahecme.com as an example, the .com part was the top level domain, which is most right hand part, right? And trahecme is the second level domain. So we can think like that: top level domain, second level domain, and after that we will see subdomains. When registering a domain name, the second level domain is limited to 63 characters. Plus, the TLD and can only it goes like that. The second level domain is limited to 63 characters plus the TLD. So it means you have a second level domain, and after that you have a TLD, and can only use A from Z and 0 from 9, and hyphens cannot start or end with hyphens or have consecutive hyphens. Okay, so let me hear it if I pronounce it correct or right. Hyphens. Subdomain. A subdomain sits on the left hand side of the second level domain. So let's repeat it. Top level domain was the most right hand part, and the subdomain is actually it sits on the left hand side of the second level domain. Using a period to separate it. For example, in the name admin.troyhackme.com, top level domain, and then second level domain, and then subdomain. The admin part is the subdomain. A subdomain name has the same creation restrictions as a second level domain, being limited to 63 characters, and can only use these rules, and again the hyphens rules. You can use multiple subdomains split with periods to create longer names, such as Jupiter servers troyhackme.com. So we can't say that the subdomain is the most left-hand part, because as you can see, we have actually not two subdomain. Actually, we have one subdomain, but we use comma, we use period to create more subdomains, more subdomain opportunities. And if you think like that, okay, the subdomain is the most left-hand part, you can miss the servers here. But totally here, Jupiter period servers is the subdomain. So we think like that. Subdomain sits on the left side of the second level domain. So how can you find the second level domain? You can start from the right. The most right hand is top level domain, which is here .com, and then before the top level domain there has to be a second level domain, right? And it is this one. And then before these second level domains, we can say there are subdomains, and our subdomain here is jupiter.servers, and we have a rule again for subdomains. There is no limit to the number of subdomains you can create for your domain name. But how? But it says here, but the length must be kept to the 253 characters or less. But here it says there is no limit to the number of subdomains you can create for your domain name. It's because of we can use here how can I say, period to create more subdomain names. Okay, it's because of this little sign here. So what is the maximum length of a subdomain? 63, and here we have our answers. And let's continue with DNS record types. DNS isn't just for websites though, and multiple types of DNS record exists. We'll go over some of the most common ones that you are likely to come across. As you can understand here, from here, we have lots of DNS record types, but these are the most common ones. A record. These records result to IP addresses, IPv4 addresses. For example, this one. There are, as I know, there are two types of IP addresses. First one is IPv4 address, and the second one is IPv6. The IPv6 came out because of the because IPv4 IP addresses won't be enough for us in the future. To solve this problem, IPv6 came out. As you can see, it's longer than IPv4, and we can have lots of devices with IPv6 than IPv4. So the IPv6 records for DNS is AAA record, yeah, and CNAME record. These records result to another domain name. For example, TroyHackMe's online shop has a subdomain name store.troyhackme.com, which returns a CNAME record shops.shopify.com. Another DNS request will then be made to shops.shopify.com to work out the IP address. So guys, here the part that I confused before, I couldn't understand the CNAME records from here well. So now we'll go to the ChatGPT here and try to learn what really is a CNAME record. DNS CNAME records are used to alias one domain name to another. Actually, we can understand easily from these sentences. So it connects a domain to another domain name to another domain. They are often employed when you want a domain or subdomain to point to the same location as another domain. The primary purposes of CNAME records include, so there are some purposes of these records. Alias creation, first one, it says actually, maybe there are lots of more than here, but these are the most common reasons. CNAME records allow you to create aliases for your domain or subdomain. For example, you might have both www.example.com and blog.example.com point to the same web server by using CNAME records. 2. Simplifying domain changes. If you need to change the IP address of your server or move your website to a different hosting provider, you only need to update the target of the CNAME record instead of changing multiple A records. Here, what do you mean by A records? It is IP records, okay? But here, if you change your server, you can just leave a note in the CNAME record, and then when someone tries to go to your website, the requests will see these CNAME notes, CNAME records, and then it will go to your new server. Okay, it's like that. Actually, I liked this reason so much. That's why I went to stop here. But anyway, let's continue here. Load balancing. CNAME records can be used in conjunction with load balancers instead of updating A records when the IP addresses of your load balancers change. You can update the CNAME record to point to the load balancer's domain. And managing subdomains. CNAME records are useful for managing subdomains. You can create CNAME records for various subdomains and point them to different locations without having to update the primary domain's DNS settings. So it's really help us to save time. It is really useful, and it will be good if you can understand this concept. Let's continue with our MX record. These records result to the address of the servers that handle the email for the domain you are querying. For example, an MX record response for tryhackme.com would look something like this one. Okay, these records also come with a priority flag. This tells the client in which order to try the servers. This is perfect for if the main server goes down and email needs to be sent to a backup server. So let's go to ChatGPT again and see the results. DNS MX, which is mail exchange records, are used to specify the mail servers that are responsible for receiving emails on behalf of a domain. These records play a crucial role in the email delivery process by directing emails to the appropriate mail servers. Here are the key purposes of DNS MX records. Mail server configuration. MX records define the mail servers that should receive emails for a specific domain. These records point to the mail server's host names or IP addresses. Here, this was for host names, okay? And email routing. When someone sends an email to an address associated with a particular domain, the sender's mail server queries the DNS to find the MX records for that domain. So let's read it again. When someone sends an email to an address associated with a particular domain, the sender's mail server queries the DNS to find the MX records for that domain. The MX records specify the mail servers that are designated to handle incoming emails for that domain. The sender's mail server then routes the email to one of the listed mail servers. priority settings. We have priority settings, which is we can define them like that, and I'll skip this one. Redundancy and failover. By assigning multiple MX records with different priority values, you can provide redundancy and failover for the email. Okay, let's keep continuing. Actually, there was another reason for. Actually, there was another benefit of MX records, which is preventing email spoofing. Guys, it's not written here, but I wanted to talk about it. So one of the benefits of MX records is preventing email spoofing. So let's continue. TXT record. Oh, actually, TXT records might prevent something. I don't know. We will see. Maybe I was wrong with the things that I say for MX record. The last thing, it prevents email spoofing, but actually probably I'm wrong. Let's continue. TXT record. TXT records are free text files where any text-based data can be stored. Be careful. Text-based data. So it is data, and it has a purpose. It's not a unuseful thing. It's useful, and we use it. TXT records have multiple uses, like it says, but some common ones can be to list servers that have the authority to send an email on behalf of the domain. This can yes. Remember the last thing that I say for MX records? Actually, it is the benefit of TXT record, not MX. Sorry. Let's read it again. TXT records have multiple uses, but some common ones can be list servers that have the authority to send an email on behalf of the domain. This can help in the battle against spam and spoofed email. They can also be used to verify ownership of the domain name when signing up for third-party services. Like I said, these are text-based data, and they have security purposes mostly. So let's read it from ChatGPT to understand it better. Where is it? It's here. DNS TXT records are used to store arbitrary text data associated with a domain. These records can serve various purposes and are not limited to any specific application. Some common uses of DNS TXT records include Sender Policy Framework. CPF is a protocol that helps prevent email spoofing. It's important. DNS TXT records are often used to define Sender Policy Framework policies, specifying the unauthorized mail service allowed to send emails on behalf of a domain. For example, you can define them like that. This record indicates that any mail server listed in the CPF record of this one is authorized to send emails for the domain, and the all indicates a soft fail policy. Include this one, and that's all. DKIM, Domain Case Identified Mail, is a method to validate the authenticity of an email message. DNS TXT records are used to store public keys that can be used to verify digital signatures associated with outgoing emails. For example, I don't know about this much. I don't know about any actually. Okay, we are now in details, and I heard about it first time. Oh yeah, interesting. Verification and ownership. Continue with this one. TXT records can be used for domain ownership verification, especially when setting up various online services. For instance, when adding a domain to a service When adding a domain to a service like Google Workspace or Microsoft 365, you may be required to add a specific TXT record to prove ownership. Like I said, these TXT records are really useful in security, in cybersecurity. So they are really important. It's really important to understand them well. That's why I'm here showing you an output from ChatGPT. So I think we should learn it better, because maybe you will have questions about these topics. Maybe you were in an interview. Service discovery. Some applications and protocols use DNS TXT records for service discovery. These records may contain information about available services such as version numbers. Okay, let's skip one. So here, making a request. What happens when you make a DNS request? Actually, what happens when you try to go to a website with your browser? First step, when you request a domain name like tryhackme.com, your computer first checks its local cache to see if you have previously looked up the address recently. If not, a request to your recursive DNS server will be made. So the reason we stored past request in our cache is about making our experience faster. If we don't how can I say, if we don't hold these records in our cache, there will be a journey in the internet. But we want to save time, we want to be fast, so that's why we have these records in our cache, in our local cache, as you can see. But if not, we will go to the second step. A recursive DNS server is usually provided by your internet service provider, but you can also choose your own. This server also has a local cache of recently looked up domain names. If a result is found locally, so our computer has a local cache and our recursive DNS server has another local cache, and these recursive DNS servers are provided by our internet service provider, or we can choose our own. Actually, it's an bypass technique to reach the websites that your country has made them forbidden. For example, your country, your government says you cannot visit x.com, and your ISP, your internet server providers, have to work with government, and the settings will be made by your ISP. But if you change your ISP, you can visit this website. Yes, let's continue. If a result is found locally, this is sent back to your computer and your request ends here. This is common for popular and heavily requested services such as Google, Facebook, Twitter. If the request cannot be found locally, a journey begins to find the correct answer, starting with the internet's root DNS server. But there is no but actually. Let's continue with third step. The root servers act as the DNS backbone. Actually, it routes our requests. Okay, it doesn't give us a record, but it knows where the records that we need. Their job is to redirect you to the correct top-level domain server. It's important, guys. What was the top-level domain? Here we saw in domain hierarchy. For example, .com, .uk, .go, .edu. These are our top level domains, and in third step, their job is to redirect you to the correct top level domain server. So for example, you are searching for something ends with edu, and the root DNS server, which is the backbone of the DNS, take you to that top level domain server, and it will be easier to find an edu domain in a edu server. We in the internet separated them one by one. For example, com top level domain servers included just .com extensions. Okay, so the logic is like that. Their job is to redirect you to the correct top level domain server depending on your request. If, for example, you request www.trahikmi.com, the root server will recognize the top level domain of .com and refer you to the correct TLD server that deals with .com addresses. The TLD server, you don't see here a TLD server, but know them, okay? Keep them in your mind. The TLD server holds records for where to find the let me hear it one more time. Where to find the authoritative server to answer the DNS request. The authoritative server is often also known as the name server for the domain. For example, the name server for trahikmi.com is this one, keepnscloudflare.com and uma.nscloudflare.com. You can see here keep.ns is a subdomain of Cloudflare, and the uma.ns is another subdomain of Cloudflare. You will often find multiple name servers for a domain name to act as a backup in case one goes down. An authoritative DNS server is the server that is responsible for storing the DNS records for a particular domain name, and where any updates to your domain name DNS records will be made. Depending on the record type, the DNS record is then sent back to the recursive DNS server. And then where a local copy will be cached for future requests and then relayed back to the original client that made the request. DNS records all come with a TTL, which means time to live value. This value is a number represented in seconds that the response should be saved for locally until you have to look it up again. Caching saves on having to make a DNS request every time you communicate with a server. So the traffic goes like that. First, just make a clear summary. Okay, I'm ready. What happens when we make a DNS, when we make a request? First, we check our local cache in our computer. If we don't any data related to our request, will go our recursive DNS server. These recursive DNS servers are provided by our ISP, but we can choose our own recursive DNS server. And it has a local cache too. We have a local cache. Recursive DNS server also has a local cache. And if the domain is not its local cache, then we'll go to the root DNS server. And the root DNS server will check our top level domain. Okay. And then it will send us to a place according to our top level domain. And the top level domain server holds records for where to find the authoritative, you got me, server to answer the DNS request. After we have our IP addresses, or after we have our response, it will be sent to the recursive DNS server. Recursive DNS server will hold a copy of that request or target in its local cache with a TTL, and then we will have our website or our target finally. That's all. Let's go to the practical part. Here, what is the CNAME of shop? We have to check for CNAME records for shop dot. Let's type the subdomain here. It is shop. And by the way, NSLOOKUP is a tool that we use in DNS operations, guys. But it's not an attack box. It's not a virtual machine, so I can't show you its features. But you will actually, you have probably heard about it, or maybe you have probably used it before. So I'll just skip this one and continue with our answers. Here, the DNS, the CNAME record for this address is shops, from shop to shops, and myshopify.com, sorry. And what is the TXT record of the, let's this time check TXT records, no subdomain, and it is our flag. What is the numerical priority value for the MX record? So let's check it. And it is 30. As you remember, we have described them here. No, it's here. Actually here, sorry, in chat. Here, our mail servers and the priority numbers, we can set them according to our rules or our policies or our needs. Let's read actually what the priority setting is. MX records have an associated priority rule value, a numerical preference. This priority determines the order in which mail servers should be used. Lower numbers indicate higher priority. Lower numbers indicate higher priority. During email delivery, the sender's mail server attempts to deliver the email to the server with the lowest priority first. If that server is unavailable, it tries the next one with a higher priority. That's it. So the MX records also holds this priority value, and here it is 30. What type of what is the IP address for the A record of this website? So let's type subdomain and let's go for A. As you remember, A was for IPv4 and 4A was for IPv6. Do we have? Yes, we have them here. And here, let's make our request. As you can see, our IP address is 10.10.10.10, but our domain was www.website.thm. But if you make this request for website.thm, you will see the same IP addresses. It means that these website and these website are in the same server. So that's all. I hope I could teach some things, you guys, teach you some things, and I hope you liked it. Thanks for your watching. Thank you for watching. Sorry my English. At the end of the lesson, my brain is not braining. So thanks for your time. Take care of yourselves. See you in the next videos. Goodbye.